Hello everyone, welcome to the fourth part of the electricity and magnetism series. In this video, we are going to learn about the various sources of electricity and its uses. So, without any further delay, let's soar the sky. Electricity has been a very important part in our day-to-day life. We use electricity to watch television, we charge our mobile phones, there are, mixer grinders and n number of other appliances where we require electricity to work. So, what are the various sources from which we can obtain this electricity? The sources will be electric cell or battery. Okay, the mains, the generator and the solar cell. We will come into the details of each and every part of them. Let's see what are these. So the first source of electricity is the electric cell or a battery. You can very easily make a battery. How? What you need is a container with two metal rods which are called electrodes and a chemical substance which can be in a solution or a paste form which is known as the electrolyte. So this is how an electric cell looks like. A glass container, a glass vessel containing an electrolyte in a solution form, that is dilute sulfuric acid over here. We have two rods of metal, one is of copper, another one is of zinc, and these are called electrodes, and this dilute sulfuric acid acts as an electrolyte. Now let's see how they work. When an electric cell starts drawing current, what happens is there is chemical reaction which starts taking place. This chemical reaction converts the chemical energy inside the electric cell into electrical energy. Then what happens is the copper rod works as a positive terminal, that is a positive electrode which is anode, and the zinc rod works as a negative terminal or a negative electrode, that is cathode, and they start giving out current or electric charge, and hence it works as a source of electricity. The most common form of an electric cell is a dry cell, and a dry cell cannot be recharged. Now what is a dry cell? We'll come into it. What is a dry cell? As you can see in the diagram, a dry cell consists of a zinc container. The entire container is made of zinc metal. Okay, so, and its base, as we have already read just now, that zinc acts as a negative terminal. So here also the zinc container's base acts as a negative electrode, that is cathode. The second point, it has a carbon rod, the rod that you can see going from the middle. It's a carbon rod placed at the center with a brass cap. This carbon rod acts as a positive electrode, that is anode. The rod is surrounded, the entire rod, the external part of the rod is surrounded by a mixture of manganese dioxide and charcoal. The electrolyte used in this particular dry cell is a paste of ammonium chloride, that is NH4Cl, plaster of Paris or flour, etc. These are the options that we use as an electrolyte in a dry cell. The outer body, except the base that is made of zinc, which is already used as a negative electrode, except that the outer body is insulated with a thick cardboard or a plastic material, both of which are extremely good insulators of electric current. Now let's see how it works. But before that, this is the diagram of a dry cell. Please pause the video, draw the diagram in your copy as it is extremely important for the examination. And if I am being able to explain the concept of dry cell and how it works, please go ahead and hit the like button. Now, when this particular dry cell is connected to any circuit or it is connected to a bulb, what happens is current starts flowing from the anode to the cathode. Why? Because current always flows from the positive terminal to the negative terminal. This is again very important point, and it will be required throughout your life till you study physics and especially current electricity, that current always flows from the positive terminal to the negative terminal. So it will flow from the anode to the cathode, that is positive to negative terminal, and then the circuit will be complete and the bulb will glow. What are the advantages of a dry cell? The first one is it's extremely lightweight. It's very light and small in size. It's not huge, it's light and small in size. Hence, it can be carried very easily, which is the second point. The third point is there is no fear of any kind of leakage from the dry cell, the electrolyte or the solution or the paste which is there inside the dry cell. It won't leak. The fourth and the last point is it can easily be used to run very simple and small electric devices. So these are the 4 advantages of dry cell. A very common example or rather application of dry cell is a torch. If you have a torch like this, what you can see over here, in order to operate or use a torch, we need 2 big cells or batteries which are connected one after the other. The positive terminal of one battery is connected to the negative terminal of another battery. So while they are connected, they complete a circuit, and when we put the switch on, the torch glows. If we take out the cells or the batteries and then put on the switch of the torch, it will not glow. So from here we can say that the dry cells generate electricity to the torch and makes it glow. So my dear students, I would request you to go ahead and subscribe to our channel to get more such quality and educational videos. When we join 2 or more cells together, it forms a battery. Why do we require a battery? When we require more electricity to run larger appliances, larger electrical appliances, that time we require a battery. Battery is nothing but joining 2 or more cells together. How do we do it? Here is a diagram, schematic diagram of a simple battery. The cells are joined side by side with one's positive terminal connected to the negative terminal of the other. 4 cells you can see are joined here by connecting the positive of one to the negative of the other and so on. And then they are joined with a bulb. And when it is joined, the bulb will glow as this battery will provide electricity for this bulb. This is what a battery is and this is how it works. The next source of electricity is the mains. What are the mains? Mains are nothing but the main switch that is present in our homes, main switch present in the factories, schools, institutions, any building, anywhere, from where we get the electricity generated from at the power station. The electricity generated there comes to the main, and from there we take that electricity via the wires and connect it to our electrical appliances like fans, lights, television, fridge, etc. and run them. So what are mains? Mains are nothing but they are the carriers of electric current from the power station to our home. As you can see, this is the main switch of my home, and from this main switch all the switchboards are connected, and from there all the electrical appliances like lights, fans, refrigerator, etc. are connected. When the electricity is generated from the power station, it comes to the electric poles of various cities and various suburb localities via electric poles. Okay, the wires carry the electric current to the electric poles, and there the electric voltage is decreased because the voltage that is the current carrying from the power station is too high to be consumed at our homes. Our appliances are not that strong enough to take that high voltage. So what happens is, at the electric poles the voltage gets reduced to 220 volt, and then via other wires and cables it comes to the main switch. And before coming to the main switch, you can always see, go downstairs and see there is a meter box where the amount of electricity consumed is also calculated, and through which we get the electricity bill every month. This is how the mains work in our homes. The third source of electricity is the generator. What is a generator? Generator is a device that is used when we have a shortage of power, shortage of electricity, or there is a power cut and we require electricity at that point of time. It acts as a substitute for electric current. What happens in a generator, as you can see in the diagram, in a generator, the mechanical energy, as the motor constantly moves, the mechanical energy of a generator gets converted into the electric energy, and that electricity is supplied to our house as a substitute for the power that is supplied by the power station. And with the help of a generator, we can also use the electrical appliances as we use them with the help of the electricity generated from the power station. So my dear students, please go ahead and share this video so that all of your friends get benefited from this. The link of the first, second and the third part of the electricity and magnetism series is given in the description box below. If you have not yet watched them, please go ahead and watch it to get the complete understanding of this chapter. The fourth and the last point or the source of electricity is the solar cell. What are solar cells? With the huge advancement of science nowadays, it is possible to convert the abundant light energy supplied to us by the sun into electricity. How it is possible? There are certain devices called solar cells which are designed in such a way that in the daytime they capture the sun's light rays, and then they convert it into electricity, and from there we can get electricity and also use them to run our electrical appliances as we do with the help of the power supplied by the power stations. In the same way, from the electricity from the solar cell, we convert the light energy into electrical energy and use it to run the fans, glow the lights, televisions, refrigerators and all the electric appliances in our house. A very important and a good advantage of solar cells are they're completely free of pollution, they're very environment friendly, and they will never ever get depleted. The source is unlimited. Just imagine, sun will never die or something, right? Sun will always be there. Till the time sun is there, the light will always be there, and till the time the light is there, we can convert that light energy into electricity. So the energy is limitless.